A company is building an IoT application where devices must send telemetry data to AWS. Because there are millions of devices and they lack DNS resolution capabilities, the company needs a scalable EC2 backend that the devices can access directly via an IP address. Which architectural choice is the most cost-effective way to achieve this? Option A, use a network load balancer with an attached application load balancer target group. Configure the IoT devices to connect to the IP addresses of the network load balancer.
Option B, use AWS Global Accelerator with an application load balancer. Configure the IoT devices to connect to the static IP addresses provided by the accelerator. Option C, use a network load balancer to front an auto-scaling group of EC2 instances. Configure the IoT devices to connect directly to the IP addresses of the network load balancer. Option D, use AWS Global Accelerator with an application load balancer with a network load balancer. Configure the IoT devices to connect to the static IP addresses provided by the accelerator.
At its core, this question focuses on how to expose services to clients that cannot use DNS to resolve endpoints. When building at scale with millions of devices, you must find a way to map static IP addresses to your backend infrastructure while keeping costs low and ensuring high availability. Understanding the technical differences between load balancers and global networking services in AWS is key to solving this, especially when constraints like DNS limitations are involved.
In my view, the correct answer is option C, using a network load balancer to front an auto-scaling group of EC2 instances. This approach is the most cost-effective because it directly addresses the requirement for static IP addresses while maintaining scalability. A network load balancer is designed for high performance and provides static IP addresses for each availability zone where it is active. This allows the IoT devices to reach the backend directly without needing to perform a DNS lookup. By using an auto-scaling group, the backend can scale to meet the needs of millions of devices efficiently. Regarding the other options, option A is incorrect because an application load balancer relies on DNS resolution rather than providing static IPs, making it a poor fit here. Additionally, adding an application load balancer to a network load balancer increases complexity and cost without benefit. Options B and D involve AWS Global Accelerator. While this service can provide static IPs globally, it comes with extra charges that make it less cost-effective than using a network load balancer alone.
For your exam preparation, always identify the specific connectivity constraints first. If a device cannot perform DNS resolution, you must prioritize services that offer stable, static IP addressing, like the network load balancer. Always look for the simplest, most cost-effective architecture that fulfills all technical requirements, rather than choosing more complex solutions like Global Accelerator, unless global traffic management is strictly necessary.